Is my screen visible?
Sir, good afternoon, sir. 15 present, sir.
Okay. Is my screen visible?
Yes, sir.
Yes, sir.
Ah, I am going to consider the flow through an inclined pipe. So here we will consider study laminar flow in a circular inclined pipe of radius A. So already we have considered the flow to be a study. So this is the pipe. So the x axis is inclined. So why I have taken this problem as inclined pipe is this will be a general case. If the pipe is horizontal, then automatically we can reduce the general equation to specific case. Now the pipe is making an angle theta with the horizontal. The radius is A and the flow is taking place parallel to the axis. Like this. Okay. The gravity will be acting vertically downwards. So it means that there will be a component of G in x direction as well as in r direction. So for flow in a pipe, cylindrical polar coordinates x, r, theta are most useful. So the first step which we have illustrated or identified is to draw the sketch and then identify the coordinate system. Then, following the procedure, we will write the NS equation in x direction. Now I am just leaving the other steps which I have told, namely assumptions and boundary conditions. Okay. So the Navier-Stokes equation in x direction is this. This is the x direction equation, the most general thing. Now, this term will be absent. What is the reason? The reason is that steady flow. So this is 0. Then one minute. See, there is a small problem here. The same thing. So there is a small mistake here. I have forgotten to correct it. So I will project some other thing so that that correction can be eliminated. Give me a couple of minutes time. Yeah. Okay. So this is the case. Now, Navier-Stokes equations, if you consider, this is rho du by dt. This here, entire thing, which is the written as left-hand side in the earlier case, this will be 0. Now, if you just go through the Navier-Stokes equations in cylindrical coordinates, somewhere I have written them. I think I have sent to you also. Cylindrical coordinate system I have given somewhere. I'm searching for it. This is Cartesian coordinates. Cylindrical coordinates where I have given.
Page number 19, sir.
Yeah, it is here. I think it is here. Let me verify. Yeah, this is the one. I was searching for this. Okay. So this is the these are the equations, Navier-Stokes equations in r direction, theta direction, z direction. Now in the present case, this z direction is nothing but x direction. Okay. You replace this z and write as x. Now, so these three equations we have to consider. What I will do is I will copy this and I will paste it there so that I can easily use it to explain. Now I can close this. X-axis. Now in order to avoid confusion, I will change this angle. Instead of theta, I will change it as some alpha. Okay. So now the x-axis equation is this. Rho, again, I have written here Vz, that I have to write it as Vx. Or I can also use a simple term U. 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 Okay, the other things will be as it is. Here, wherever Vz is there, I have to write U. U. So instead of Z, I would write X. X. So this will help you to know in case you have by mistake used some other coordinates, then also how to correct all will help you this one. Right. See, so this is x-axis equation. So this x-axis equation so simplification, this will be 0. Then why this is 0? Why this is 0? Because the flow is only in x direction. So VR is 0. Similarly, it is axis symmetric flow. So dou by dou theta 0. So this is 0. Then this will also be 0. How you get it? I am putting a question mark here. And you have to explain. Come on. Anyone? Why this is 0? So this is 0 by virtue of
Initial velocity.
no, 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 no.
Continuity equation.
So that what I suggest all of you, you write the continuity equation in cylindrical coordinates and then use your assumptions and automatically you will get that dou u by dou x will be 0. Okay. Now, on the right hand side, since the gravity force acts in vertical direction, 1 minute. Okay. So since the gravity force acts in vertical direction, we have seen earlier. It is acting vertically downwards. So the component of this we have to find out in this direction. So this will be G sine R. It will be G sine alpha. So again, what we can do is we can replace sine alpha by dH by dx. See, if I take this is alpha. So this is also alpha. So if I say this is dH, and this has dx. So what is sine alpha? Sine alpha is equal to dH by dx. dH by dx. So what we can do is it is minus because as x is increasing, as x is increasing, h is reducing. So therefore, because it is sloping downwards, so therefore, we can write as minus dH by dx. No. So therefore, what happens is this entire thing, this entire equation will now become, actually here you are having rho g. Okay, this is gx is written as this, and rho gx be rho G dH by dx minus, and this rho G is replaced by gamma. Followed? So now, so what happens? So this entire left hand side is 0, and coming here, this is 0, this is 0, and this is 0. So you are left with this term only, right? Now what we do is combine these two. So this is minus gamma dH by dx, or also I can write this as dou H by dou x also, minus dou P by dou x. So if I combine these two, I'll get this as minus dou by dou x of P plus gamma H. So this is this one. Right? And sorry, this term I've forgotten. This term, see, this is again, I have to correct it. See, there is a small, this is U. So, this term will be present because U is not 0. So this is 0, this is 0. This entire thing is 0. And this we have combined to this term. So therefore, you will be left with this. Your x direction equation will be this one. So the remaining steps are very clear. What we can do is, I will simply combine this. What I will do is this I can write it as d by dr of r du by dr. Suppose if I differentiate this, what do I get? I'll get this one. 1 by r dou by dou r of r dou u by dou r. Right? Now, I am simply using a notation to replace this. See, this is now what our idea is. As we know, the velocity of flow is 0 here and zero here, and in between the velocity will be varying something like this. So this is u. So this is u, which is a function of r. Our objective is to find out expression for u as a function of r. So when we consider this expression, this will not change with r. See, this dH by dx or pressure, they will not change in the radial direction. In the radial direction, they will not change. So, as far as the radial direction is considered, I can say that this term is a constant. Or, in other words, I can say that it is not a function of r. So this is more important. So I am designating it as lambda. It's only for the convenience of writing. So this is our short form of Navier-Stokes equation in x direction. Now, if you integrate it twice, you will get this equation, right? Now, what are the boundary conditions? The boundary conditions are, this is your pipe. So this is your central axis. And this is how we are measuring r. And the radius is a. So at r is equal to a, that means either this point or the velocity is 0. So this is one boundary condition. This is one boundary condition. Now, what is the second boundary condition? We don't have the second boundary condition. We have only one boundary condition. But what we can use our common sense is that when the velocity is 0 here and here, and at r is equal to 0, naturally the velocity will be maximum. So velocity is maximum, that means u will be maximum here. So when u is maximum, it means that du by dr is equal to 0. So du by dr is equal to 0 at r is equal to 0. Now we have, this is the first boundary condition, and this is the second boundary condition. So at r is equal to 0, now if you substitute, you will get C1 is equal to 0 and C2 is equal to so if I substitute, if I differentiate this with respect to r, I will get du by dr. But before that, when I use r equal to a, so this will become a square and this is log a. So it must be 0 at r is equal to a. So this will be one equation. And using du by dr, you will get 0, du by dr is equal to 0. And using those two, you will get C1 is equal to 0 and C2 is equal to minus lambda by a square by 4. Now this you can verify. I need not work it out here. It is simple differentiation and then confirmation. So therefore, if you substitute the values of C1 and C2, you will get this equation. U is equal to 1 by 4 mu d by dx of, I am substituting back the value of lambda. Okay. So this is the equation. So this is parabolic equation, right? Now, we will get, suppose the pipe is horizontal. So that means what? Horizontal means what?
Fixed plates.
Huh?
Fixed plate.
What? No, it is pipe. I am saying that the pipe. So your angle, this angle alpha will be 0. Alpha is 0. So when alpha is equal to 0, what will be sin alpha? 0. So you will get, that is dh by dx. This term, the second term, will be vanishing. So for horizontal pipe, you will simply get u is equal to 1 by 4 mu dP by dx into r square minus a square. Now, have you followed? All of you.
Sir.
So, in fact, we could have started with the horizontal pipe and derived. In that case, what happens? What will be the difference? Suppose I had taken horizontal pipe. So, in that case, if I take horizontal pipe, what will be this value? See, this is the pipe. This is our x direction. And this is a vertical direction. G is acting like this. So, what is Gx?
Zeros.
So, Gx is equal to 0. So, the derivation of horizontal pipe is simpler. Only the difference between a horizontal pipe and inclined pipe is only the presence of this. In the case of inclined pipe, you will get this additional term. That is the only difference. Right? Now, the same thing I have just written here. Now we want to find out the other things. 1 minute. లేకొస్తున్నాడు I will be back within 10 minutes. తలుపు కొట్టి నాన్నగారు క్లాస్ చెప్తుంటే క్లాస్ రా ఇటు
బయట అక్కడ కూర్చున్నావా బయట కూర్చున్నావా బాల్కనీలో కూర్చున్నావా తప్పు
వరకు కొడుతున్నా నాన్న కదా మా అమ్మరా
బయటకి తీసుకురండి
వాడికి మా అమ్మ పడుకుంటే ఇష్టం లేదు. I'm back. So this is the expression for the velocity. This is for a horizontal pipe. Because why it is for horizontal pipe? Tell me. Are you there?
Yes, sir.
Yes, sir.
Yes, sir.
Ah, this is valid for horizontal pipe. Why? Because gamma H term is not there. If you add gamma H, it will be for inclined pipe. Right? This is the only difference. That's the only difference. Now, what is maximum velocity? How do you get maximum velocity?
At center, sir.
Yes. U corresponding to R is equal to 0. So you substitute R is equal to 0. So what you are getting? Minus 1 by 4 mu dp by dx or dou p by dx into a square. Did anybody find out something peculiar in this? This is U maximum. Anybody? Anything funny? U maximum is equal to minus a square by 4 mu dou p by dou x.
R is equal
Nobody.
to S.
This
R
is
is equal to
R is equal to 0.
R is equal to 0, sir.
You have substituted R is equal to 0.
కానీ పైన
Huh?
అంటే పై స్టెప్ లో u ఈజ్ ఈక్వల్ టు 0, r ఈజ్ ఈక్వల్ టు ఏ, బి వాల్యూ తెలుసుకోవడం కోసం అలా సబ్స్టిట్యూట్ చేయమన్నారు కదా సార్, అందరూ అలా ఆలోచిస్తారు.
See, for getting U maximum in this equation, we have to substitute R is equal to 0. So we have substituted. So we got this. There is no mistake in our procedure. There is no mistake in the procedure. What is the result you got? Okay, this is not. So what we got was, I will. What we got was U is equal to minus one divided by 4 mu dou P by dou X into A square. So this is what we got. Now my question is, are you able to find out any peculiarity in this equation, in this expression? What is U? Or U maximum? This is U maximum, whatever. What does U represent? What does U
Horizontal.
represent?
Horizontal
U
velocity.
represents? Don't say horizontal velocity. U represents velocity in
X direct.
X direction. Okay. Velocity in positive X direction. Velocity in positive X direction. Now what you are getting? Right hand side, what is this sign?
Negative.
How can it be? What is the justification? Huh?
Flow is from left to right to left, sir.
No, we have taken flow from left to right only. That is our positive X direction. See, you can be can in no case be negative. Because U is the velocity in the flow direction. Followed?
Yes, sir.
So U always is positive. That means what? There must be something which is negative on the right hand side. Which is the possibility? What is mu?
Viscosity, sir.
Can viscosity be negative?
No, sir.
What is A?
Radius at center.
Radius. A square. A square. Can it be negative?
No. Pressure.
So mu cannot be negative. A square cannot be negative.
Pressure.
So what should be negative then?
Pressure.
Don't say pressure. There is no pressure here. In the equation, you don't have pressure. You have, what do you have?
Pressure gradient.
Pressure gradient. So the pressure gradient must be only negative. So what is pressure gradient? It is P2 minus
atmosphere.
P1 divided by X2 minus X1. See, this is given.
One tomato, onion, green and red bell peppers.
See, somebody's other voices are coming. So this is dou P by dou X means dou P by dou X or dP by dx. So P2 minus P1 by X2 minus X1. Now X2 minus X1, can it be negative? This is always positive. X2 minus X1 is always so automatically this must be negative. That means in the direction of flow, P2 is less than P1. Then only flow is possible. Do you understand? All of you.
Yes, sir.
So if the pipe is inclined, if the pipe is inclined, so what must be the thing you deduce? For horizontal pipe,
Sin alpha.
1 minute, P2 is less than P1. This is for horizontal. For inclined pipe, what must be the correction? What you have to replace? P is replaced to be replaced by
P sin alpha.
P is to be replaced by, if the pipe is inclined,
P sin alpha.
P sin alpha. You are all not following. P is to be replaced by P plus
Gamma H.
So this is for inclined pipe. Inclined pipe. So that is the physical significance of this minus sign. Right? Now, all of you work out this. All of you get this. I have given how to do it. The discharge may be found by integrating annuli of width dr. So what we will consider is a circular element whose width is dr so the rate of flow dq is equal to u into 2 pi r dr. UR means u function of so for you substitute the equation u is equal to 1 by 4 mu into, I am using the general expression lambda r square minus a square. So for UR, you will write this expression and integrate it r is equal to 0 to a. So this you will get q. Come on, all of you do. I will break for 10 minutes here. All of you work this and then we will proceed for the next thing. నేను వస్తుంటే నువ్వు ఎక్కడికి వెళ్తావు?
Yes, sir.
That mu also you have taken there. That 4 mu 1 by 4 mu lambda.
ల్యాండాలో అది కూడా ఉంది.
Okay, it doesn't matter. That constant lambda, we will assume that for the time being absorbs mu also. Okay. Now 1 minute. Why you have written pi by 2?
Sir, you're cancelling, sir. 2, I mean 1 by 4
Okay.
and 2, sir. 2 pi r.
Okay. Go ahead. So
Q is equal to now.
the only correction you have to do is the mu term. You should not forget.
Yeah, okay, sir.
Okay. R4 by 4 minus a squared r square by 2. R is equal to 0 to a. Okay. A4 by 4 minus a squared r square by 2. So a4 by 2. So a4 by 4. So pi by 2 lambda a4 by 8. Okay. Lambda is 1 by mu. Right. That is Q. Okay, correct.
Shall I stop it, sir?
Yes, you stop.
Thank you, sir.
So this is what you will get. Q is equal to pi a4 by 8 mu. I have written instead of delta p by dou p by dou x, delta p by L. If the pipe length is L, then delta P is the pressure difference between the entrance and exit, and L is the length of the pipe. This is for horizontal. So if it is inclined, you will get Q is equal to same thing, pi a to the power of 4 by 8 mu into, here you will get, in place of delta P by L, now what is we have to write in place of delta P by L? We have to write delta or okay, delta P plus gamma H by L. Delta, that is the difference between P plus gamma H at 1 minus 2. Okay, because here we have tried P plus gamma H. For delta P I am saying you should not write this is what you have to write. So P1 minus P2 plus gamma H1 minus H2. So these are the final equations. These equations I have given for horizontal pipe. All of you in your notes to write the corresponding equations for an inclined pipe. That means you replace P by P plus gamma H. So if you just use this expression, this is the average velocity. This is average velocity. So use this expression rewrite it to get delta P. So now what we can do is we can always take delta P as the head loss. So it is HF. HF is nothing but delta P by gamma.